Hi everybody, this is Gigi from Kauai Community College. In this video, we will be talking about the derivative of e to the x. Okay, so the question we are asking here is, what is the derivative of e to the x? Now, in order to do that, we need to understand what e is. E, by definition, is a number that would satisfy, E is a number that would satisfy this limit definition. And what limit definition is that? That's say the limit as e to the h minus 1 all over h. That limit is going to equal to 1. And to illustrate that, here is the function. So here's the function e to the h minus 1 over h. If we are looking at this function right here, we can see that when h is approaching 0, the function value is approaching 1. Okay, so what is e? E is the number so that this limit will equal to 1. Okay, now what does that have to do with what we're looking at? We are looking at the derivative of e to the x with respect to x. By definition, that is limit as h go to 0 of e to the x plus h minus e to the x all over h. Okay, so something to notice too is, when do you add an exponent? You add an exponent when you are multiplying exponential expressions with the same base, right? So e to the x plus h is the same as e to the x times e to the h minus e to the x over h. And if you notice, you will say that you have e to the x in common right here. So we can factor out e to the x. So let's rewrite this limit as h go to 0 of, okay, and let's go ahead and factor out e to the x. When we factor out e to the x, what do we have left inside? E to the h minus 1, right? That would be this part right here. And as we were just saying, that limit is 1. Okay, so this is going to be 1. And if that go to 1, then the limit as h go to 0 of e to the x will just be e to the x. So we are saying the derivative of e to the x is e to the x. I think this is the only function where the derivative is looking exactly the same as the function itself. And that's why e to the x is so special, right? The derivative is itself.